Hey, you are here to learn something about clipper circuits. So let me tell you what is here in this video for you. So all of these things in this video. If you want to go for some specific thing in this video, then you can directly jump to the timestamp and you can save your time. What is clipper circuit? So basically, clipper circuit are those circuit who cut clips off a portion of input circuit or erase a portion of input circuit without changing or without distorting the rest of the signal. So this is basically the clipper circuit. You know, this circuit is also known as clipping circuit, limiters, clippers, slicers, etc. So these are the different names of clipping circuit. So after knowing this clipper circuit, the next thing comes in our mind is where do we use these circuits? So let me tell you the applications of clipper circuit. This circuit is basically used to modify an input waveform using signals, or simply you can call it as wave shaping circuits. So to shape the output, this circuit is used. The another application of this clipper circuit is to provide over voltage protection. You can use devices like diode, Zener diode to achieve those things. We have seen what is clipper circuit, applications of clipper circuit. Now it's time to see different types of clipper circuit. And to explore that, let's jump into the video. So this clipper circuit is mainly divided into two categories: series clipper and shunt clipper. The series clipper is further divided into series positive clipper, series negative clipper, then series positive bias clipper and series negative bias clipper. The shunt clipper is subdivided as shunt positive clipper, shunt negative clipper, shunt positive biased clipper and shunt negative biased clipper. Now, this series positive bias clipper is further divided into series positively biased positive clipper and series positively biased negative clipper. Now, series negatively biased clipper is also subdivided into series negatively biased positive clipper and series negatively biased negative clipper. So, like these two clippers, even shunt clippers are also subdivided as shunt positively biased positive clipper and shunt positively biased negative clipper. The same way, shunt negatively biased positive clipper, shunt negatively biased negative clippers. So this is the full classification of clipper circuits. So together this bunch becomes 12 types of clipper circuits. So if we rearrange this structure and divide them into two groups, then we can see clipper circuits divided into two groups: series clipper and shunt clipper. Now we are going to explore the tricks to plot output waveform of series clipper and shunt clipper. And now we are going to explore the trick using which you can plot the output waveform in just 30 seconds. So amongst all this clipper circuit, first we'll start with series positive clipper. So this is the circuit of series positive clipper. Now let's go for our 4-step trick. The step number 1 is to mark out terminals. These are our two output terminals, positive one and negative one. In step number 2, we need to mark diode terminal. So we need to mark the diode terminal which is facing the positive of output terminal. So that is positive. So step number 2 is done. In step number 3, draw the waveform of all the sources. How many sources are there in this circuit? We have only one source, that is AC source. So we need to plot the waveform, or we need to draw the waveform. So this is the waveform. Step number 3 is done. And step number 4 is draw output waveform from this. So here the key thing is, if positive terminal of diode is facing the positive terminal of output, that means you need to clip off the positive cycle of the signal. That means here in this case the output waveform will be like this. So this is how you can plot the output. So this is step number 4. Now we'll go for the series negative clipper and we'll follow the same process. This is the circuit and this is our trick. These are the two terminals, positive, negative. Step number 1 over. The diode terminal facing positive terminal of output is negative. Step number 2 is over. Draw waveform of all sources. Here we have only one source. So this is our input signal. So from this, negative terminal of diode is facing the output. That means we need to clip off or we need to remove the negative cycle from the output. So our output waveform will look like this. Isn't it very simple? But now we are going for a series positive biased clipper. This series positive biased clipper is further divided into two categories: positively biased positive clipper and positively biased negative clipper. So amongst these two, first of all we'll go for positively biased positive clipper. So here we have the circuit and the trick is this. So first we need to mark out the points. This one is positive, this one is negative. Step number 1 is done. Step number 2 is mark diode terminal. So the positive terminal of diode is facing the positive terminal of output. Step number 2 is over. So in step number 3, draw waveform of all sources. Here we have one AC source and one DC source. So for the DC source, mark out the terminal. The positive of this DC is facing towards the positive of output. That means our input sources waveform are like this. This is AC source and this blue waveform is of this DC source. How to mention whether this DC source will come over here or will come over here? If the positive of this DC source is towards the positive of our output terminal, then DC line will be on positive side, and if there is negative terminal facing the positive one, then the DC line will be on negative side. That we'll explore in our next clipper circuit. So now our step number 3 is done. Now it's time to draw output waveform. In previous two cases, we have either clipped off full positive cycle or full negative cycle. That means our reference was 0 volt line, right? But when we have particular amount of DC voltage in our circuit, then that DC voltage will be our reference line. So now whatever signal we want to clip off, we will use this DC line as our reference. So now we'll draw the output waveform. So which terminal is facing the positive of output is positive. That means we need to clip off this section of the waveform, the section which is above the DC line, because now this DC line is our reference. So the output waveform will look like this, right? Now let's go for the next series positively biased negative clipper. This is the circuit. Now step number 1, will mark out the output terminal. In step number 2, this negative terminal is facing the positive output. In step number 3, we need to draw the waveform of all the sources. So here we have AC as well as DC source. And the positive terminal of this DC is facing towards the positive terminal of output. That means the input signal looks like this. Now step number 3 is done. Now it's time for step number 4. The negative of diode is facing towards the positive output. That means from this DC reference line, you need to clip off the full negative signal. So your output waveform will look like this. In this video, we are only covering the tricks. If you want to understand how exactly all this thing works, then I have prepared a separate video for that and you can check out that video later on. The link will be in description and above here in card. Now let's go for the next clipper circuit, which is series negative biased clipper. This clipper is also subdivided into two categories: series negatively biased positive clipper and negatively biased negative clipper. So among these two, first we'll go for series negatively biased positive clipper. So this is the circuit and our 4-step procedure. So let's mark out the point. This one is plus, this one is minus. Step 1 is done. The positive terminal of diode is facing this positive. Step number 2 is done. There are two sources, AC as well as DC, but the negative terminal of DC is towards the positive terminal. So this is how we should draw the input waveform. The negative of this battery is facing towards this positive. That means our DC voltage will be in negative side. So step number 3 is done. Now step number 4, which terminal of diode is facing the output? The positive terminal. That means all the lines above this should be removed, and the output waveform will looks like this. So this is series negatively biased positive clipper. Now we'll go for series negatively biased negative clipper. So this is the circuit, our 4-step procedure: plus terminal, minus terminal. Step 1 is done. Negative terminal of diode is facing the positive one. Step number 2 is done. Voltage source 2, AC and DC, we had plotted. Step number 3 is also done because this negative is facing the positive one. And step number 4, this negative terminal is facing the positive. That means we should clip this negative section. So the output of waveform looks like this. Till now we have seen all the series clippers. And you know what? To create this type of video, it requires a lot of hard work. If you want to appreciate our hard work, then you need to just hit that like button. And if you think that this type of video is useful for you, then you can hit that subscribe button. And now we are going for the shunt clipper. This is the circuit of shunt clipper, the two terminals. The process will remain same. Mark out the terminals, plus minus. Mark diode terminal. This positive terminal of diode is facing the positive of output. Draw the waveform of all sources. Here we have only one source. So now this positive terminal of diode facing the positive of output, that means we need to clip off the positive section of the signal, and the output will looks like this. Here you can see the output is not exactly 0. Why it is not 0? That I have explained in my next video, where I am explaining full shunt clippers with live simulations. So you must check out that video after this one, where you will get all the minor details of shunt clippers. So now we'll go for the next shunt clipper, that is shunt negative clipper. This is the circuit. Step number 1 is to mark out points. Step number 2 is mark out the diode terminal. So it is the negative terminal. We have only one source. So let's plot the waveform. So in next step, we need to look for this negative terminal is facing the positive terminal of output. That means we need to clip off this negative signal. So the output will look like this. The same way you can see this is also not 0. And why it is not 0? That I have explained in my upcoming video. Now let's go for shunt positive biased clipper. There are two types of shunt positive biased: shunt positively biased positive clipper and shunt positively biased negative clipper. Amongst these two, first we'll go for shunt positively biased positive clipper. So this is the circuit, and we'll go for the step number 1. We'll mark out the terminals. Step number 2, mark the diode terminal. The positive terminal is facing. So step 1 and 2 is over. Step number 3, draw the waveform of sources. So we have one AC source, one DC source. This positive of DC, it's towards the positive of our output terminal. So the input looks like this. Now step 3 is over. So it's time for step number 4. The positive terminal of diode is facing towards the positive of output. That means whatever waveform is above this 3-volt reference line, we should clip off that thing. And the output looks like this. Now we'll go for shunt positively biased negative clipper. This is the circuit. Step number 1 is to mark out the terminals. Step number 2, diode terminal. In step number 3, both the sources. So this positive is here positive. So our input will be look like this. And now in step number 4, the negative of diode is facing towards the positive. That means the waveform below this line we should remove. And the output looks like this. Now if we go for shunt negatively biased clipper, then there are two types: shunt negatively biased positive clipper and shunt negatively biased negative clipper. So amongst these two, we'll go for shunt negatively biased positive clipper first. This is the circuit diagram. Step number 1, positive negative. Step number 2, diode terminal. Step number 3, plot the waveform of sources. So these are the waveforms. And now we need to go for step number 4. This positive terminal is facing the positive of output. That means we should clip off this section and the output looks like this. Now if we go for next shunt negatively biased negative clipper, then the circuit looks like this. Step number 1, mark out the terminals positive negative. Step number 2, diode terminal. Step number 3, there are two sources and the input signal looks like this. And step number 4, the negative terminal of diode is towards the positive terminal. That means we should remove this section of the waveform. And the output waveform looks like this. And now finally it's time for a bonus clipper circuit, that is dual clipper. The circuit of dual clipper looks like this. So for this circuit also we'll apply our 4-step formula. Step number 1 is to mark out the terminals. In step number 2, mark out the diode terminals. First we have this negative terminal and then we have this positive terminal. Here we have total 3 sources, 1 AC and 2 DC. So in step number 3, draw the waveform. This battery's positive terminal is facing the output positive terminal. So its waveform will be on positive side, and this battery's negative terminal is towards the positive terminal of output. And that is why its waveform is on negative side. Now we'll go for the step number 4. And in that we need to draw the output waveform. So we'll start moving right hand side. First diode comes, that is D4, and the negative terminal of this D4 diode is facing towards the positive. That means this section of the signal we should remove, because this is the line of this battery. So this section we should remove. Now after removing this section, at this point we have only this much of waveform, right? So now let's keep this thing in mind and draw the next waveform. Now the positive terminal of this diode is facing towards the positive. That means this section of the signal we should remove, because this line is represented by this battery. So we should remove this section as well as this section. So the output will looks like this. So this is how you can draw the output of all types of clipper circuit. Here we have learned how to plot the output waveform using 4-step simple trick. But what if you genuinely want to understand how exactly this circuit functions? Then then you must check out my this video. In that video I have explained all these things using live simulation in multisim. So see you in that video.